Hi everyone. In this lesson we want to give a brief introduction to how you factor polynomials. Now one of the things we often do when factoring polynomials, or one of the reasons that we do factor polynomials, is to be able to solve equations, and sometimes those get mixed up in students' minds. So just as a brief reminder, we simplify expressions, but we solve equations. Okay, now if we look at these examples that I have down here, you'll notice that there is no equal sign. And so these are not equations that we would solve. These are expressions that we would simplify. And the way that we simplify expressions like this, about all you can do, would be to factor anything that might be in common. So for example, in this first example, there's a common factor of 3 between the 3 and the 6, and there's also a common factor of y in the y squared and the y. So if I were to factor that out, I would have to multiply the 3y by what to get 3y squared? Well, that would just be a y. Okay, so, and then what would I multiply 3y by to get 6y? That would be 2. So always double check. If I redistribute the 3y to the y, to get this 3y squared, and the 3y distributed to the 2 gives me 6y, and so I'm sure that that's my answer. And that's the way you always check your factorization, is just multiply it back out and be sure you did it correct. If I move over to this next example, I've got an x and y and an x and a z and an x and a w. It looks like there's certainly an x in all those, and then I've got the numbers, the 8, the 10, and the 14, and it looks like there's a common factor of 2 that would go into 8 and 10 and 14, and then I've got the x as well. So I asked myself, what do I multiply 2x by to get 8xy? Well, let's see, I'd have to multiply 2 by 4 to get 8, and then I'd have to multiply by y to get this y in here. Then what do I multiply 2x by to get 10xz? Well, I'd have to multiply by 5 to get 10, and z to get the z. And what do I multiply 2 by to get the negative 14? Well, that would be a negative 7, and then I also need a w. Again, you can multiply it all back out to see we did that correctly. And also just double check and make sure there's not any common factors left in what's over here, in case we didn't get it all the first time. Okay? Alright, when we move on to this next example, you'll notice that there is a common factor. There's an a plus 5 here and an a plus 5 here. And what you don't want to do, if I'm factoring, is I wouldn't want to FOIL this out. I wouldn't want to multiply this out and multiply this out. If you recognize something's in common there, I can go ahead and factor that right out. I've got a plus 5. And when I factor a plus 5 out of this larger expression right here, I'm left with a minus 2. And then when I factor the a plus 5 out of this larger expression, here's my plus sign, and I'm left with the a plus 1. All right, so again, in your mind, try and visualize, think of this as a single quantity, and if I were to redistribute this whole quantity to the a minus 2, I would get a plus 5 times a minus 2. That's this right here. And then I distribute that over the plus sign right here, and I'd get a plus 5 times a plus 1. That's that right there. Okay, so if I take this one step further, notice that I have some common terms inside these brackets I could combine. I've got an a and an a, that makes 2a, and I got the negative 2 and the 1, that makes negative 1. So that was sort of a quick little somewhat tricky way to factor that ends up being much easier than multiplying those out that students often make the mistake of doing. When I move over to this next example, you see something similar to this one. You see there's an x minus 6 but a 6 minus x. Now those aren't exactly the same, but they are related, and this is another trick that if you see binomials that are reversed this way, like x minus 6 and 6 minus x, and you're looking to factor them out, what you can do is you can refactor it. Instead of a plus 2, if you put that plus as a minus, that minus will magically flip that 6 minus x around to x minus 6. Just double check. Notice if I multiply negative 2 times x, that's the same thing as 2 times negative x. And the negative 2 times the negative 6 here, that's a plus 12, and that's the same as 2 times 6 up here. So it really does work. But now that I've done that, you can see that I have a common factor of x minus 6, and then I can pull that out. And when I take the x minus 6 out of this whole quantity, I'll be left with 5x squared. And when I take the x minus 6 out of this whole quantity, I'll be left with the minus 2. Okay, and there's nothing left in here to factor, so I'm basically done there. If I had 4 terms, these haven't been grouped together, but I noticed that if I were to group these first 2 together, I would have a common factor of t squared that I could factor out. And if I group the second 2 together, if I factor a negative 2 out, a miracle happens. I get another t plus 6 left. Now that's a fairly common happening when you see 4 terms in algebra. Often that will happen, and then you can go ahead and factor out, if these are the same, t plus 6, then you can factor that out. And when you factor it out of this first part, you'll have t squared. And when you factor out of the second part, you'll have a minus 2. Okay? Likewise on this problem, if I were to group the first 2 together, I would get y squared that's in common. And if I factor these 2, or group these 2 together, I can pull out a 2, and that'll leave me 2 minus y. And then I look back and I say, oh, this is y minus 2. So what I'll do is I will implement my trick. Instead of factoring out a plus 2, I'll factor out a minus 2, and that will magically turn that around to give me a y minus 2. So I got a negative 2y plus 4. That's exactly what I got up here. Or if I would have recognized, I could have just reversed them up here as well. All right? Either way, sometimes you don't always recognize that. So now I have a common factor of y minus 2 in here and here. So when I factor it out of this first term, I'll be left with y squared. And when I factor out of this term, I'll be left with minus 2. Okay? Now, as I mentioned earlier, all of these problems have been expressions that we just simplify. But the following problems, now you're seeing an equal sign in them. These are equations that we solve. You always solve equations, and the way we solve them is by first simplifying, or in this case factoring, the expressions. Okay? So if I have this equation and I'm looking to find the x that makes it true, we typically want to get 0 on one side, unless it's a linear equation. These are not linear because of the squares and the cubes in them. If I factor out what's in common, there's a common factor of 2x. I can factor out 2x out of 2x leaves 1. 2x out of the negative 4x squared leaves negative 2x. And then I'm going to make use of the principle of zero products. If I have 2 numbers that are multiplied together to equal 0, the only way that can happen is one of the numbers has to be 0. 0 is a very special number that the only way you can multiply to get 0 is for one of the factors to be 0. That's not true of any other number. If, for example, I had 2 numbers that were multiplied together to give me, say, 3, one of the numbers wouldn't have to be 3, would it? One of the numbers could be 1.5, and one of the numbers could be 2. See, but if I ever have 2 numbers that are multiplied together to give me 0, the only way that can happen is one of the numbers, either this one or this one, has to be 0. Well, that's what I have up here. I actually have 3 numbers multiplied. I got a 2 times an x times this other 1 minus 2x and equal to 0. So the only way that can happen is one of those numbers has to be 0. Well, obviously that first number, 2, isn't 0, right? But this second number, x, could be 0, or this third number, 1 minus 2x, could be 0. So x equals 0 is one of the solutions, or I can solve this one. I would get x equals 1/2. Okay? Now if I come up here and I plug in 1/2, 2 times 1/2 is 1. If I plug in 1/2 over here, 1/2 squared is 1/4. 4 times 1/4 is 1, and 1 minus 1 is 0. So it really does work, and you can see the 0 works. That's even easier to see. All right? So here's a last example. If I'm trying to solve this equation, what I want to do is I want to get 0 on one side. So the first thing I'm going to do is bring the 7x squared over on the left-hand side, so I get 0. And then I'll factor out what's in common, and I see that there's a common factor of 7x squared. And if I factor that out, that'll leave me 3x minus 1. And I have, if you want to think of this x squared as 7 times x times x. So we don't have to worry about the squared right now. But the same thing, I actually have 4 numbers multiplied together to give me 0. And the only way you can multiply to get 0 is one of them has to be 0. Well, obviously this first one isn't 0, so that's not a solution. But this one could be 0. And of course that's the same thing as this one being 0. And the last thing is I could have that last number, 3x minus 1, equaling 0, and that would mean that x is equal to 1/3. So in this case, my solutions are going to be just x equals 0 and 1/3, and that's the only two possibilities that'll make that equation true. And you can verify that. Go ahead and plug that in if you'd like, and see that it really does work. Okay?